Okay. Um. Over there, we can't see all of it. We've got a couple of expressions. We want to find the least common multiple. First one, we have x minus 3 times x plus 4 times x plus 2. And the second one, we have I think that's right. I kind of smudged a little bit of it. Okay, so we have these two expressions. We want to find the least common multiple. Well, the least common multiple needs at least these three. Because least common multiple's got to contain everything that either of these does. Now, what else does it need? Well, does it need an x plus 2? Well, no, it's got an x plus 2. Does it need an x minus 3? No, it's got an x minus 3. Does it need an x plus 1? That doesn't have an x plus 1. So we got to put an x plus 1 in there. I didn't get to look at everybody's paper in detail, but that's what I think I was seeing. Am I right? What you got? Okay, seems to be what everybody got. So that's very good. Now we go make it a little harder. Not much. Okay, now we have these two. We can factor them. And we need to factor them because we need it to be in this form before we can figure out what in the world the LCM is. Okay, well, we factor them. We get x minus 2 times x minus 5 and x plus 4 times x minus 5. Okay, well, what's the least common multiple? Clearly, we need x minus 2 . Crashed and then resumed. So I don't know how much of that I actually got recorded. Still, it's recording, so let me say what I just said. Better if you see it while it's written out, but and again, I blame Zoom for this, but I think we're still having problems with our network where the network is unable to do what it needs to do. There's something else that just went on there. I don't know if that's going to show up on the video. So it's not our network. There's a denial of service attack that's probably still going on. So it's hackers that are doing it. In any case, we want the least common multiple of these two expressions. So we go through this expression. We need all three of these. So we need x minus 3, we need x plus 4, and we need x plus 2. Otherwise, it won't be a multiple of this expression. Then what? Well, then this expression needs an x plus 2. But yeah, we've already got one. Okay. It needs an x minus 3. We've already got that. It needs an x plus 1, and we don't have that, so we go ahead and add it. Yeah. There's our least common multiple, and as I think I said, it looked like everybody got that. I didn't look at all the details of what was written on the paper, make sure all the numbers were right, but everything looked right. There were 4 factors, and everything was good. And then we have these two expressions. Now, in order to do this, you have to have the expressions in factored form. So we have to factor this expression, we factor this expression. In factoring, we get this one factors to x minus 2 times x minus 5. This one factors to x plus 4 times x minus 5. So what's our least common multiple? Well, we go ahead and write out the first one. Okay, we need this and this, or it's not going to be a multiple of this. And then what do we need here? Do we need an x plus 4? Yeah, we don't have one. So we're going to go ahead and add an x plus 4. But we don't need an x minus 5 because we've already got it. Well, that's pretty much it. If you have two expressions in factored form, it's pretty easy to find the least common multiple. There's not that much to it. If you get used to it. Now, factoring can be tricky, especially if you like have a cubic. But for right now, just confine ourselves to expressions like this. Okay, so let's say now that I wanted to add 3 over x squared minus 7x minus 10 to, oh, let's say 5 over x squared minus x minus 1. How are we going to add these two? Well, to add two fractions, you need a common denominator. The most convenient common denominator is the least common denominator. And the least common denominator would be the least common multiple of your denominators. Okay, well, to find the least common multiple of these talking good today, denominators, we factor the two denominators, because we're not going to find the least common multiple unless we got the denominators factored. And of course, I'm using the same factors we have here, but ordinarily you would have to stop and factor, so I'm going to include that step. So now I've factored the denominators, then I find the least common denominator. Least common denominator is what? Well, it's the least common multiple of the denominator. So as before, we write down one of the denominators. Then we look at the other denominator and see what we're missing. We're not missing an x minus 5. We've already got it, but we do need an x plus 4. Now what do we do? Well, I have to write a little bit smaller here. I have to write as neatly as possible. Okay, right here is the first term. Okay, if I get too cramped, I might have to rewrite it, but let's just see what we can do. Yeah, I'm gonna need more room. There's no way I'm gonna squeeze it in there. Make it halfway legible. Okay, so I'm gonna do this in 2 lines. We're gonna have this plus 5 over x plus 4 times x minus 5. Okay, we need this denominator. So we look at the denominator here and say, okay, is anything missing out of the least common denominator? Yeah, x plus 4 is missing. So we need an x plus 4 in the denominator, and we get that by multiplying by a fraction whose denominator is x plus 4. Now, we don't want to change the value of this expression from here for any x. So we better multiply that by, that's why we better use denominator x plus 4. Because now x plus 4 divided by x plus 4 is whatever x is. This is equal to this. When you divide two things that are equal, you get 1. So we're just multiplying by 1 here. We're going to change the form of the thing so we can add it to this one, but we haven't changed its value. Okay, then we multiply on this one. We've got the x plus 4. We've got the x minus 5. Okay, well, here's the x plus 4. Here's the x minus 5. We don't have the x minus 2. So we got to multiply by x minus 2 over x minus 2. So now our expression becomes, we multiply the two things and we get the product of the numerators and the product of the denominators. Okay, so same denominator, it's x minus 2, x minus 5, x plus 4. And then we add that to 5 times x minus 2. And then that's divided by the same denominator. Got to write it pretty small. Probably can't read it. I can't even read that. Kind of put a parenthesis around there to don't mix up the denominator and try to multiply them or something. Okay. So this is three times the quantity x plus 4 plus 5 times the quantity x minus 2, all divided by this denominator, x minus 2 times x minus 5 times x plus 4. Now, in order to understand the steps well, you really need to understand how to add and subtract fractions with numbers. Okay, numerical number for numerator, number for denominator. So we really need to review that because I noticed that people did, almost everybody, almost nobody was able to add two fractions with numbers on the midterm. Okay, so we really got to upgrade what we understand about adding fractions. Okay, well, in any case, what we get then, let me write it out a little bit bigger now. Get this over this whole denominator. And all that follows quite simply if we just do this step and do it correctly. Okay, we multiply the numerators. We're going to get 3 times the quantity x plus 4 in this numerator. We're going to get 5 times the quantity x minus 2 in this numerator. And both are going to have the same denominator. The denominator is going to have x minus 2. This one does, and this one does. The denominator is going to have x minus 5. There it is in this denominator. There it is in this denominator. Going to have x plus 4. Well, there it is in this denominator, and there it is in this denominator. So the denominators match. So all this stuff follows. This follows pretty much immediately from this step, which you can read, and this step maybe, which you can almost read. Okay. We continue then by simplifying, because we want to simplify this thing completely. We want to simplify the numerator. So we use a distributive law. So we get 3x plus 12 plus 5x minus 10. All that divided by our denominator, x minus 2 times x minus 5 times x plus 4. So that's equal to this. And that's then equal 3x and 5x is 8x. 12 and negative 10 is 2. Now, we could at any stage multiply out this denominator. I'm not even going to do that because I assume everybody knows how to use the distributive law by this point. But one reason we don't multiply out the denominator until we're done is we need to factor that numerator and see what we get. Okay, the numerator isn't quite factored. The numerator would be 2 times the quantity 4x plus 1. And that would be over x minus 2 times x minus 5 times x plus 4. And at this stage, we see that this factor of the numerator, 4x plus 1, doesn't appear in the factored form of the denominator, so this can't be reduced. Okay. So this is in its final form, unless somebody wants you to expand that denominator, in which case you just multiply everything out. Okay. And if you do that, then you probably want to multiply the numerator out. I consider this to be the simplest form because it's the factored form of the expression. I think open math might agree with me and they might disagree. And if they disagree, well, go with what they want. Okay. Whoever's asking you to do the problem, you know, I would actually take either as long as you check to be sure that nothing divides out of this thing, that none of the numerator is repeated in the denominator. Okay, so that's pretty much a complete example. Now I'm going to give you another example to work on and see if you can do that. Of course, you're going to have to do the whole thing now. So let's go ahead and do this. Okay, so here we have the subtraction we want to do. This is 4x over x plus 2 times x plus 3. Then it's minus 7 over x plus 3 times x minus 2. Now, your greatest common denominator is the least common multiple of these denominators. It's got to have x plus 2 and x plus 3. That's from here. And then it's also got to have both of these factors. It has x plus 3, so we don't need it. But it doesn't have the x minus 2, so we're going to have to add that from here. And those circles and underlines don't have to be there. I'm just making them to make sure we understand where they come from. Okay, so now our 4x over x plus 2 times x plus 3. To make the denominator into this, well, what are we missing from the denominator? We're missing x minus 2. So we've got to have an x minus 2 here. And of course, we've got an x minus 2 here. We have to have x minus 2 here so that this is equal to this. but this thing is really equal to 1, so it doesn't change the value of this quantity. Then we have minus 7 over x plus 3 times x minus 2. And that's got to be multiplied by what? Okay. We need this denominator. We've got x plus 3. We've got the x minus 2 here. We need the x plus 2. Now, what's this equal? Offset this a little bit. This is equal to this. This is equal to this. Okay. This is then going to be 4x times x minus 2 over x plus 2 times x plus 3 times x minus 2 minus 7 times the quantity x plus 2 over x plus 3 times x minus 2 times x plus 2. That's going to then equal 4x squared minus 8x. And then it's going to be minus 7x minus 14. It's this numerator minus this denominator. And that's over the whole denominator because these denominators are equal. We can just operate on the numerator. So there we've got it. Now, if you just have 4x times the quantity x minus 2 minus 7 times the quantity x plus 2 here, well, you want to multiply those out. The reason you want to multiply those out is so we can look at this numerator, which comes out to 4x squared minus 15x minus 14 divided by x plus 2 times x plus 3 times x minus 2. Okay. Now the question is, does this numerator factor? That's kind of a little bit complicated. We're going to get what, 16, and we're going to get 224, 240. Okay, now I'm using a shortcut, but I can see that this thing doesn't factor. Still, you would try to factor. Okay, and that was a little bit involved. The factor takes a little while to check out some of the possibilities, but you do what you can. And you find that it doesn't factor, so you're not going to simplify it. But sometimes this factors, and one of the factors might equal one of these factors, and then you got to do a little more. So mechanics, everybody did quite well. Down to this point, and even to the next point, nobody actually multiplied out and simplified the numerator, but that's easy to do once you practice a little bit and understand how to do it. Nobody's going to have trouble doing that. So that's pretty good. Did pretty well here. Okay, now we're going to make sure this is visible. Yeah, it's visible. We're going to talk about square roots. But first, we're going to lay the foundation. So what's x squared times x squared? What's q to the fourth times q to the fourth? What's a plus b cubed multiplied by a plus b cubed? What do the rules of exponents tell you for each one of these? Doesn't mean you got to multiply out the cube of a plus b. Okay, just use the rules of exponents and see what you get. And then what's x to the fifth squared? What's z to the negative third squared? And then what's x squared over y to the fourth squared? Just to kind of review the rules for exponents so we can set the stage for talking about square roots of expressions. Okay, so x squared times x squared. Now you could write that out as x times x multiplied by x times x. And of course, that's x times x times x times x. And that's x to the fourth. Well, another way to do that is say, okay, x squared times x squared equals x to the 2 plus 2. Why 2 plus 2? Because you got 2 of them here, you got 2 of them here, 2 and 2 makes 4. Two to the fourth times 2 to the fourth equals 2 to the 4 plus 4. When the exponents get big, we don't want to have to write it out like this. We want to just imagine what we're going to see. Okay, so we can see, we can imagine, okay, that's 4 q's written down, that's 4 more. That makes 4 plus 4. That's 8. So we kind of do this type of a step in our head. If it was q to the 431st times q to the 431st, you wouldn't want to have to write out 431 q's twice. Okay, but you understand that that's what you do. So you're going to get 2 times your 431 q. Well, 431 plus 431. Okay. It even works like a binomial or any other expression. If you multiply the cube of something by its cube, that means you're going to have 3 of these here. You're going to have 3 of these here. So you're going to have a plus b to the 6th power. All that makes sense? Very close to the way you wrote it out, but we want to use the rule that says when you multiply the same base, you multiply 2 quantities with the same base, you're going to add their exponents. Okay, then we have x to the 5th squared. Okay, now we could write that as there's x to the 5th, 5 of them, and we're squaring it, so we've got to multiply that by itself. Okay, well, that equals x to the 10th, because there are 10 of them there. Okay, if we use the rule, we're just going to do x to the 5 times 2. The power of a power means you multiply the powers. And why you multiply the powers? Because, well, in this case, you've got 2 of these, which is 2 of these. Each one of these has 5. How many do you have then? You got 2 of them, you're going to have 2 times 5, which is 10. Okay, so that's x to the 10th. Now, using the same reasoning, you don't have to write out z to the negative 3rd. That'd be 1 over z cubed and so forth. It'd be a little bit of a pain to write it out. You can still use the rules of exponents. That's z to the negative 3 times 2, which is z to the negative 6th. Then you have x squared over y to the 4th quantity squared. Well, you square the numerator and you square the denominator. That's going to be x squared over y to the 4th squared, which is x to the 2 times 2, not plus 2 times 2, divided by y to the 4 times 2, which is x to the 4th over y to the 8th. So there we have a number of examples. Now the assignment for square roots of expressions doesn't come up until Friday, so we'll be able to talk about this on Wednesday. But what I want you to do is make sure that you understand all this and understand how we're using the rules for exponents to match what we would do if we wrote it out in detail, okay? Because you're going to need to use the rules for exponents in order to deal with square roots of different types of algebraic expressions.